Next is regarding solving tower of Hanoi problem with n-disk under the laboratory program 5, that is 5B. So before we go to the program, let us see the concept of tower of Hanoi problem with n-disk. So tower of Hanoi is a mathematical puzzle where we have 3 rods and end disk. Okay, 3 rods and end disk. So these 3 rods we can take it as or we can also call it as 3 pegs. So we can take it as source, destination and auxiliary. I'll tell what we are going to do over here. The objective of the puzzle is to move the entire stack to one rod obeying the following rules. For example, let us take n is equal to 2. Okay, n is equal to 2. Now over here this is A, let A be the source, this is source, and n is equal to 2 means we have 2 disks. Okay, so while placing the disk also, the larger one should be below and the low one should be above the 1. So that is, let us name this as 1 and this as 2. So the objective of the puzzle is to move the entire stack to another rod. Now this is our source, okay, and this is our destination, and I'll tell why I'm using an auxiliary rod. Okay, you'll come to know why we need this auxiliary rod. Our aim is to move this entire stack into this, okay, by following these principles, So I'll repeat, tower of Hanoi is a mathematical puzzle where we have 3 rods and end disk. We have 3 rods, that is A, this is B and this is C. We have 3 rods and end disk. End disk is equal to, here we have taken as 2. The objective of the puzzle is to move the entire stack from source to destination obeying the following rules. So the first condition is only one disk can be moved at a time. Only one disk can be moved at a time. That means in the each iteration you can move only one disk at a time. You cannot move 2 also at a time. Okay, that is first condition. Next, each move consists of taking the upper disk from one of the stack, that is this from one of the stack, and placing it on top of the another stack. That is, only a disk can only be moved if it's uppermost disk on a stack. That means you cannot move this disk. First you have to move this particular disk, then only you can move this particular disk. You cannot move directly this disk. So first condition was only one disk move, only one disk you can move. Second condition is uppermost disk can be moved. You cannot, meaning is you cannot move the lower, whatever is here, this you cannot move. Only the upper disk can be moved. And third condition is no disk may be placed on top of smaller disk. That means you cannot place, now if this is the destination, you imagine, upon smaller you cannot place the bigger. Upon smaller you cannot place the bigger. So this is the third condition. So you should follow these 3 rules. So let us see, we have a source, we have an auxiliary and we have a destination. Aim is getting these 2 disks at this particular position. Okay, so let us keep as it is. In the first logic, if you want to move this entire thing, we want to move to the destination. So how is it possible? So over here, this is source, this is destination. So these 2 disks should come. So if I move this particular disk, condition is what? I can move only the uppermost disk. If I move this particular disk over here, then smaller come first and then upper comes first. So I cannot move directly this to this particular iteration. So what I can do is, this smaller one disk, I can move it in the first iteration, I can move it to this. So what will happen in the iteration 1? In the first iteration, I can move the smaller to that. So bigger one will be over itself. The disk is over here and this is source. In addition, you can give A name. I gave rod A. Okay, that is source. And then here I moved it to auxiliary, the smaller. So smaller came over here. Name it as 1 and that is auxiliary. Okay, and B if you want. And then C C is empty. I just, in the first iteration, I just shifted over here. So this is destination. This is destination. I just shifted this disk from here. So here we got the disk. Now in the second iteration, what can I do? Can I move this? This is a bigger disk. Can I move directly to this? Yes, I can do that step in the second iteration. In the second iteration, I can move it from source. Now your source is empty. Auxiliary will have the smaller disk with name 1. Now your destination will have the bigger disk. So that is 2. This is destination. This is auxiliary. Now you see bigger disk is being placed in the second iteration. Now it is big. So what were the rules? I'll just repeat. Only one disk can be moved. I moved one disk from this from this to this, and I placed over here. In the first iteration, I got it over here. Only one disk I moved. Since why I did that? So because I cannot shift. If I shift this to this, then I should place this upon this. So that's why I moved this disk to auxiliary. I moved smaller one to auxiliary. One disk in one iteration is done. And each move consists of moving upper disk. Yes, I moved the upper disk and I maintain the constraint. After that, no disk may be placed on top of the smaller disk. That constraint also we agreed. In the second iteration, what I did is I moved this second disk to this. Only one disk move, and it's only one disk left. So uppermost itself it's that. So I moved over here. Now over here, when I check, this is uppermost. From this I can move it to this. So source is over here as it is, auxiliary is also as it is, and destination will now have this is disk 2 and this is disk 1, and this is destination. Now this is how many iterations you took? 3. So when you have n is equal to 2, the number of moves is 2 to the power n minus 1. So it is 2 to the power 2 minus 1. It is 4 minus 1, that is 3. So you had 3 moves. If you check over here, you had 3 moves. So this is the logic. This is the logic how it works when you have n is equal to 2. Let us solve for n is equal to 3 also, but I'll just repeat the algorithm again. Tower of Hanoi is a mathematical puzzle where we have 3 rods and n disk. 3 rods, so you can take it as source, auxiliary and destination. The objective of the puzzle is to move the entire stack to another rod. This entire stack to this particular rod, obeying this rules. So only one disk can be moved at a time. So only one disk can be moved. Each move consists of taking only the upper disk from one of the stack. Only the one of upper disk you can move, and no disk may be placed on top of a smaller disk. So these are the 3 conditions you need to follow when you actually do the performance of the Tower of Hanoi problem. So this is an application of the recursion. So I already told regarding application of it is an application of stack. So application of stack is recursion. Under the recursion, we are learning regarding the Tower of Hanoi problem with n disk. So let us solve for n is equal to 3. N is equal to 3. So when is n is equal to 3, you have a rod. I'll just give the source A, then this is B, and this is C. Okay, so here I have 1, 2, 3. So I'll name it as 1, 2, 3. My aim is actually to move this to this. So this is a source, this is an auxiliary, and this is a destination. So this is my first, when we read, right, that is n is equal to 3, this mini disk are there. So our first iteration, what we have to do? I need to place the topper one over where? If I place topper one over here, just imagine, if I place topper one over here, then I can place second one. I should place second one over here. If second one comes over here, I cannot place third one on top of that. So what I can do is, the topper one, I need to place it over here. I'll tell why. If I place topper one over there, then second one I can place it over here. When I place second one over here, and first smaller disk over here, next smaller over here, and next higher over here, this smaller disk I can shift back over here, and then I can move this way. So that is how the process goes on. So let us see. So in the first iteration, I moved this to the last destination, and I'll be doing the following iteration. So over here I have, this is A, this is 2 and 3, so B as it is, and then in C I I moved the smaller one, so that is 1. So this is first iteration. So in the first iteration what I did is only one disk can be moved, and it should be top of the bigger one actually, but here since it was empty, so it is only over here, so one disk I moved. Next iteration what I'll do is I'll move this to this, so it will be A will be having only bigger one, so that is 3, and B will be having medium one, that is 2, and C will be having a smaller one, that is 1. So I moved this to this. Okay, I moved this to this, so this is A, B, C. So this is first, this is second iteration, and in the third iteration, what can I do is, I want to shift this to this, because bigger one should come over here, right? So before that, I'll shift this back to this, above this. So what can I do? In the third, this is the third iteration. In the third iteration, it is A is over here itself. 3 is over here itself, and then on top of higher, this is higher, right? Second one is higher. I can place the smaller one. I placed one over here, and now your C destination is left free. So this is regarding third iteration. Now in the next iteration, what can I do is I can in the fourth iteration I should move this to this. So it will be empty over here. This is fourth iteration, empty over here A, and your B is 2 and 1, and your C will be having this number as 3. This number as 3. Okay. This number as 3. So over here, write as it is as A. 1, 2, then 3. 1, 2, and then 3. Now what you can do is, I want to shift this 2 to this. So before that shifting 2 to this, I need to shift 1 to this, because I cannot shift directly this disk. So I shifted 1 over here. So over here, this is fifth iteration. So this is a smaller size actually. So let me write it again. So this is disk number 1, and disk number 2 is over here, and disk number 3 is over here. Now what we have to do is, now it's in order, I can shift this to this. So in the sixth iteration it is, this is 1, this will be empty, and now upon the bigger one you have the second disk, that is 2 and 3, and this is C. And in the seventh iteration it is shifting this to this. So it is empty, A is empty, and B over here, and C will have 3, then 2, and then 1. So now your destination is being shifted from source to destination, as it is how it was there in the source. So disk 1, 2, 3. So totally there are 7 iterations. So if we see the formula, number of disk move, if you want to see, 2 to the power 3 minus 1. So it is nothing but 2 to the power 3 is 8, 8 minus 1 is equal to 7 iterations, that is 7 moves of the disk when it is taken for the 2 to the power 3 minus 1. So this is regarding the how the process of tower of Hanoi works. So this process is actually happening with the concept of recursion. So if you know the concept of recursion is what? It calls, the function is called by itself. It is calling the function again and again. So its recursion is made for solving problem that can be broken down into smaller repetitive problem, and it is also good for working on things that have many possible branches and are too complex for an iterative approach. So the main benefit of recursion approach is it allows the program to take advantage of the repetitive structure present in many problems. Like if it has to call again and again the same function, repetitive structure, then recursion is being used. So in the Tower of Hanoi problem, we are going to use the concept of recursion. So let us see the problem. So before we go to this is the function we are going to use to see the recursion function for solving the Tower of Hanoi problem with n disk. So before we see regarding this function, let us go to the main function and check what is there in the main. So void main function, we had int choice and n, and then postfix. So this is the continuation of the pi program. So the main part was I told I'll be explaining here. So character postfix 100. So you already know what postfix I had defined over there. And then while one infinite loop over there had one application, stack application. So printf I have given stack applications. Enter your choice. That means over here I'm going to enter my choice as one as enter your choice is a printf statement. One choice I'll be giving to the evaluating the postfix expression, and the second choice I've given for this solving tower of Hanoi, and third one to the exit. Okay, and that's why I've given enter your choice, and I'm reading the choice. For example, if you give 1, then it will go to the enter a postfix valid postfix expression. So over here scanf %f postfix, evaluate of postfix function was explained in the previous session. So after evaluation of postfix, you're getting the result, and the result will be displayed. So this is regarding the case 1. You're entering a valid postfix expression, you're reading the postfix expression, and then you're evaluating the postfix expression. Case 2 is regarding enter the number of disks. Now let us solve this program. Let us solve this particular program with number of disks is equal to 3, because we'll take a standard one that is equal to 3. So we'll read it as 3. Now tower 3 and A, comma C, comma B. Okay, I'll tell what these terms are. So this, when I tell this, it will call for the tower function, and printf total number of moves are, as I told, if you want to see 3, the total number of moves is 2 to the power 3 minus 1, so that is 7. So same formula is being used here, 2 to the power 1 minus 1. So again I'm converting that into typecasting into int. So power of 2 comma n 2 comma n minus 1. So this gives the total number of disks. For example, if it is 3, it will give it as 7. So this is regarding case 2, and then it is default is invalid choice. Case 3 is written, and then it is end of switch and end of menu and end of main. So this is regarding the main functions. Now when we call the tower function, for example, enter the number of disks, we had given 3, then it will call tower of 3 comma ACB, that is source to destination using the auxiliary. Then it will come directly to this void tower function. So over here we had seen that same 3, source was A and destination was C, and auxiliary was B. So when it comes to this particular function, if n is equal to 0, in case if it was n equal to 0, now in case if instead of 3, if we had 0, it will come directly out of this particular loop, and it will print directly the statement over here. So this entire logic of these 3 statements, whatever, if n is equal to 0, it will return. If not, this tower and this printf and this tower, I'll explain this in entire thing using the recursive algorithm. That is, again, we are using recursive algorithm. I'll be tracing using the tree structure. So that will be easy, where I can show you how the recursive process works. So it's better if you have a recursive functions, recursive algorithm. It's always better if you show the tree structure. So it will be easy to trace the particular program. So you know what is recursive, calling the program itself. For example, calling this particular function itself. So here I called tower, again you're calling a tower, again you're calling a tower. So these 3 lines of execution, as well as in case if n is equal to 0, it has to return. If not, these 3 lines needs to be performed. That I'll be showing in the new page. I'll explain you in the new page using the tree structure. So just remember, n value was equal to 3, right? N value was 3, and initially we called tower of 3 ACB, tower of, I'll just write T, okay? Tower of Hanoi, I'll write it as 3 comma A comma C comma B. Now what was there in that particular function, I'll just write for you over here. We tower of that program, we had int n is nothing but 3l, right? And then source, and then destination, that is C, and then you had auxiliary using this. Within this function you had, if n is equal to 0, then it will return. This was our function. If n is equal to 0, I'm just writing in a shortcut, it is written. If not, if n was not equal to 0, else 3 statements with it, that is tower itself n minus 1. N minus 1 means n minus 1 comma source acceleration destination. I'll write it as in short, okay, source, that is I'll write SAT, source acceleration and destination, source acceleration and destination, source auxiliary and destination. Here also I'll write source, destination and auxiliary, not to get confused. Okay, so this was the first tower. After that you had a printf statement. In the printf statement I'm telling that move disk percentage d, that is move disk percentage d is, that is actually for n, percentage d from percentage c to percentage c, and after that I'm writing over here n comma source comma destination, okay, that means I'm printing n value, source and destination. This percentage c is for destination, and this from c, 1% c is for source, and this is for destination, and then percentage d is for n. So this was the printf, so kindly listen over here. And next tower, again we had a tower of function. In that tower again we had n minus 1 comma auxiliary, comma destination, comma source. So this was the tower of a function. No, so when you have this, right, when you have this, if n is equal to 0, then return. So this will not execute because n is equal to 3. Else you have to perform this, you have to perform this, you have to perform this. So this performance what is having within the tower, again you're calling a tower function, then again you have a printf, and then again you're calling a tower function. So this is happening recursive. So this recursion I'll be showing in the tree structure. So this is the n is equal to 3, so this is the main, n is equal to 3. Now within this I'll show you the tree structure of this. So I'll write over here in the middle. So we had t, so this, let it be over here. We had t, and then you had 3 of a, c, b. So you know what is a, c, b? A is source, c is destination, and b is the auxiliary. Remember this, students. A is source, c is destination, and b is auxiliary. When that is this itself, and after that you will check if n is equal to 0. In our case n is not equal to 0. So now we'll show you the tree structure. Just remember that since it has 3 over here, just draw the 3 branches, so that I'll tell you regarding what we have to do at the end. So just draw the tree structure. So within this you have, it's not equal to 0, one statement is this, one statement is this, and one statement is this. So just write again. When you're using function, again mention it is in the oval shape. Whenever you use a function, you mention it is in the oval shape. Okay? Oval shape. So here I'll mention over here this, and when this second one is the printf statement, put a box over here. Printf statement, put a box, and then again a oval shape, then again a oval shape. So over here first tower is what? N minus 1. So call that function again, t of n minus 1. What is there? N is 3 minus 1 is 2, right? 2 over here. I wrote n minus 1, that is 2. Then you have source auxiliary destination, SAD, it is nothing but source. If you see this particular function here, source acceleration destination, so that itself you write. What is source here? In this, this is source, this is destination, and this is auxiliary. So you should write in the form of source auxiliary destination, source auxiliary destination. So source is A, and auxiliary is B. Source is A, auxiliary is B, and destination is C. So just when it in this, for this tower of Hanoi, this is the iteration. These 3 are the iteration. For this function, these 3 are the iteration. So what was source? This was source, and this was auxiliary, and this was destination. Just for your brief. So that is nothing but this SAD. I'm right. In short, I'm telling SAD. That is SAD. When it comes over here, this tower, it is ADS. That is auxiliary destination and source. So come back to this. So I performed this one tower, I wrote as it is. Then you have print move disk percentage d from percentage c to percentage c. So what is the meaning? Percentage d is n itself. So what is that n value? So move disk 3 From where to where? From percentage C to C. That means what? From source to destination. So I'll just write in short, move this 3 from source to destination. So what is source A? What is destination C? So just refer this and write it over here. Move this 3 from A to C. After that, in this branch, you just write again this function ADS. So tower of Hanoi n minus 1. N minus 1 is 2, comma, auxiliary destination and source. What is auxiliary destination and source? Auxiliary is B. Auxiliary is B. Okay, I wrote auxiliary destination and source. Destination is C. Destination is C, and then you have source. Then you have source. So that is nothing but A. That is nothing but A. So it is nothing but same over here. ADS, ulta of this, BCA. So this is the 3 functions I have performed. Now when it comes to again this now tower, now this is for this tower these 3 operations. So come to this particular first branch over here. So it is calling again a tower function. So where it will go? It will again go to this. It is calling again this function, so it will go again to this function. Now instead of 3, your function will have 2. Here it will be 2. Here it will be 2, and instead of that ABC, you will be having, here let it be 3 itself, but here I'll write just, you will have 2 comma A comma B comma C. Now this is source, this is destination, this is auxiliary. So say tower function called is 2 comma A comma B comma C. 2 comma A comma B comma C. So when it calls tower, again it will go over here, 2 comma A comma B comma C. So A is source, A is source, A is source, B is destination, and C is auxiliary. In the second case here, so I'll just write over here. I'll write it in a blacking. For the next tower function, this is N, and here when it calls, this is source now, and B is your destination, and C is your auxiliary, and C is your auxiliary, and C is your auxiliary. Okay, this is source, this is destination, and this is auxiliary. Don't get confused, students. For this function, source, destination, auxiliary, you applied. When you applied source, destination, auxiliary, you applied these 3. You wrote these 3 statements. So you wrote these 3 as this: source, auxiliary, destination. So upper S had represent for this, and then printf, and then this tower you wrote. Now again this is an iterative, right? It is a recursive. Again it should call what? When it tells, whenever it finds tower, it will come back and call this particular main function itself, main tower function itself. So it will come over here. Now your main function is in the form of what? Source, destination, and auxiliary. So I wrote as it is. In below I wrote it for the tower function: source, destination, and auxiliary. Now for this again I have 3 branches. Why? Again when it is source, destination, auxiliary, again these 3 lines should be function. So I'll mention a 3 branch over here. 3 branch over here. One is for this. One is for this. Okay, one is for this. One is over here, and one is over here. So for this I'll mention again it is a function, right? Why? For tower 2 also, here n is not equal to 0. See, it's recursive. It goes back to this top function itself. Instead of 3, now it is 2 here, and this variables will be A, B, C, A, B, C, A, B, C. This variables will be 2 comma A comma B comma C. And here again it is source, auxiliation, and destination. In us, whatever is there, that will be changing. Okay, so that will be changing. So I'll just, this function is been called. So you just remember that in one tower, in this one line, it is n minus 1, and it is sad, and printf, and then again it is n minus 1, it is ADS. Just you remember these 3 lines. That's it. Don't see these lines. Just you remember source, auxiliary, destination, source. Okay, now you came to this particular function. Now your source is this, destination is this, auxiliary is this. Anymore you will not see these things because this was performed for this one. So now whether n is equal to 0, n is not equal to 0. So it will be tower of n minus 1. What is your, this is n minus 1. First statement is n minus 1. So it will be 1. It will be 1. When it is 1, what it will be again? Next 1. And then you have source, auxiliary and destination. Source is A, write A as it is. Auxiliary and destination. Auxiliary is C and destination is B. You wrote as it is. Is it clear with this? How to write? First tower is nothing but n minus 1. write the format of source auxiliary destination. So source was A, auxiliary was C, and destination was B. So I wrote ACB. Next statement is what? Printf. What is printf? Again, printf is what? Move to your move disk percentage D n. Your n is what? Move to from source to destination. Printf statement was from source to destination. Source to destination. What is your source to destination here? Move to from A to B. Move disk to. Okay, it is move disk to from A to B. So this is regarding the second statement of this tower of Hanoi recursive statement. Next, again it will perform the function. So what is this particular function? Again tower n minus 1 is 1, and then it is ads, that is auxiliary destination and source. So ads, so it will be cba, auxiliary destination and source. So it is cba. So this is regarding this. This is a printf statement. It's end. I don't have to do any job. So this tower, it is being performed. This tower is being performed. After that, once it perform this particular tower, come back over here. Again over here you do the tower function. So what it will happen? Okay, so this needs to be solved first. This needs to be solved first because we are going again now. It is left root and then right, left root and then right. But I'll tell you how the flow goes actually, how it calls. So when it is this, right, tower of 3, it will call this particular function within this particular printf, and then it calls this. Now within this I called tower 2 abc, right? I called tower 2 abc. Then again I performed this, that is tower 1 acb I got, and move, and then I got this. Now again it is a recursive, right? So I'm solving this left branch itself. So again recursive means this will be what now? Again here it is, instead of this question it will be tower of whatever n value, n comma source comma d comma auxiliary, right? Source comma d comma auxiliary. So here I'll use red ink. So this is in the form of source destination auxiliary. Source destination auxiliary. Okay, source destination auxiliary. So this was in the, now this is in the tower 1 comma a comma c comma b, a comma c comma d. So I'll just 1 second, I'll just try. So this is being, for this I got first this and then this, then this. Now what, again this is a recursive. So again this will have 3 branches. So just try to do this, and then again it has a printf, and then again it has a one more branch. So let us go again in the recursive. So here it will call tower of n minus 1. What is n minus 1? It is 0, and here it is calling ACB. So you just see the function, don't get confused. ACB means source destination auxiliary. ACB means, again we got it as, this is in the source destination auxiliary. Source destination auxiliary. Same we got source destination auxiliary. So what it will call? 0 comma it will call n minus 1, right? N minus 1 is 0. SAD, SAD means what? B, C it will call. 0 comma A comma B comma C, because it will call, once it will call SAD. This is for SAD, tower SAD. This is for ADS, and this is for printf. So it will call SAD. So ABC. Printf is what? Move disk 1 from source to destination. So move n value is 1 from source to destination. So it is A to C. After that, again this tower. So tower is, again you will get 0. ADS means ult of this. So it is written as BCA. So this I did for, this is how the process works. First tower recursion, I call 3, one tower function, one printf, again tower function. Now again it will go to this tower function. Again it will be solved like tower printf tower. Again it will go over here. Again it will go to this tower function, then printf, then this tower function. Now when it is 0, what it will do? It will return. So this tower function done. Then again it will go back over here. It will come to this. This is also written. I'll tell how this process works. So it will return. Further it doesn't execute. Now it came back over here. Now right branch was left out over here. So over here again it will call 3 branches. So one is for the tower, and one more is for the printf, and one more is regarding again tower. Okay. We'll try to solve over here itself. So I'll just minimize this tree structure because we need to do the right hand also. So here I'll call one is this oval, and this printf I'll make small, and I'll make it as this much. Okay, now when it is tower 1 CBA, that is now source destination auxiliary. See this, source destination auxiliary. So here it is SAD, here it is ADS, and here it is source to destination. So tower of n-1 is 0. What is source auxiliary destination? Source is C, auxiliary is A, and destination is B. Write as it is, C A B. That is source is C, auxiliary is A, and destination is B. I wrote as it is. And print, that is 1, move disk, I'll write M, okay, move disk 1 from source to destination, from C to B. After that, once you wrote from C to B, after that what you're supposed to write is your ADS. Again, tower of n-1 is 0, and ADS, again, ADS means what? ABC, right? ABC as it is. Now it is 0, since n value is 0. If, see, it will call this tower function. If n is equal to 0, return. So it will return over here, and here also return. So this side branch is done completely. Now it came, now we will solve over here. Now we'll try to solve over here. Okay, now it is tower 2. So obviously it will call one more tower function and printf function, and then again it will call one more tower. So here tower 2 means what? Now BCA means, see this structure, SDA, it is in the form of S, source destination auxiliary. So this is SAD, that is source, this tower function SAD, and this is ADS. So tower of n-1 is 2 minus 1 1. SAD means source is B, auxiliary is A, destination is C. So it is 1 comma B comma A comma C. After that, printf, as it is n value, source to destination move, so it is B to C. And here it is ADS, so it is tower of 1 comma ADS, so it is ulta, ACB function is been called. Now again tower is been called, so this you check, I'll write in a heading, it is in the form of n comma S comma D comma A. Form is S comma D comma A, and here also it is S comma D comma A. Now for this again it will be having 3 branches. I'll write over here, okay, those 3 branches. One is this, and one is printf over here, and then again it is structure. So when it is tower of this, what it will be? T of n-1, it is 0, and then this, you know, branch is SAD, source auxiliary destination. Source is B, BCA, printf n value, that is move disk 1 from source to destination, that is from B to A. After that, this again branch has ADS, so it is tower of n-1 is 0, ADS is CAB. After this, you know, again it will call this tower function, but you know n is equal to 0, so it is written. This also will be written. Now come back to this particular branch. Over here you again have 3 towers. So one is this function, one is printf, again one more is this particular function. So this is again in STA form, this is SAD and this is ADS. Okay, so SAD means tower of 0 comma ABC, 0 comma ABC. Okay, and here printf, that is move disk 1 from source to destination, that is A to C, and here it is tower of n-1 is 0 comma ADS is nothing but BCA. So this is regarding this branch, and then n value is 0, so it will come return, and this also will be written. So this is the entire tree structure for the tower of Ni when n is equal to 3. I'll just repeat, just see this particular function, we had tower function. If n was 0, then this would, n is equal to 0, return 0, else these 3 lines we had. So let us go back to this, so I'll just write over here. Okay, I'll just write here tower of n comma A comma S comma D, that is auxiliary comma auxiliary comma source comma destination, and if n was equal to 0, we had written, else we had these two, tower, printf, tower. So I'll repeat this particular section. Initially we called tower 3 and our source ACB, that is nothing but source, destination and auxiliary. So if you had seen in this main, we had called ACB. So it will call that particular function. We know that A is a source, C is a destination and B is the auxiliary. Now for this, within this, n was not equal to 0. So I told if n is equal to not equal to 0, then these three statements need to be executed. So this was one. First line was the tower, second was the printf, and next was the tower. So whenever I told, when you get the recursive, try to use the tree structure. When you use the tree structure, it is actually left branch, then it is root, and then it is the right branch. So you have to go this way from left to right. So first you have to read from the left, then to the root, and then right. While printing, I'm telling, while printing, finally when you print the answer, you're going like this, left, root, right. So it came to this, and it came to this tower, you wrote this move, and then you wrote this tower function. Now for this, after that, this is the left branch, tower. For this tower branch, I again wrote this particular, for this tower again I'm calling a recursive function. So again it has three lines, so tower, printf, tower. Again for this tower you have tower, printf, tower. So similarly for this again one more tower, tower, printf, tower. So this got end. So right hand side also you had tower. So again tower, tower, printf, tower, again tower, tower, printf, tower. So this is how the entire recursive structure shows. So once you call this tower came. For this tower again it will go back to this particular function. Again it has to perform these three. So it performed these three. Again for this it called these. It called this. For this, since it was 0, it returned, and done. This was also 0, so it returned. So this my left part branch was done. Okay, for this it's done, and then again it came to this tower, and this execution is 0, so it returned. So it came back, and right branch it executed. So for that tower again 3 lines I wrote. Until where? Until we had that n value equal to 0. Now this tree structure, if you know to write, then to write the output it's very easy. So left, root, right? So if you see over here, first come to the left branch, below from the left branch. So first statement will be printed as this, move, that is I'll write here, output I'll just write over here, that is we are seeing from the left to left, root, right. So left branch of this is this, come to the below one. Here this is written, we don't have anything, it is written. Here we have a printf statement. Whatever printf statement you just write over here. So first printf statement is move 1, I'll just write move 1 from A to C, okay. After this printf statement is done, go back, we don't have any printf, go back over here, this is the left, for this is the left branch, nothing to print over here. Then it came to the root, it printed this, then it is again right, you're going like this, then go back, this terminated, go back over here, left nothing is there. In the middle root it is there, so that root needs to be printed, that is move 2 from A to B. Come to the right branch, right after this, see I'll just repeat again. I came to the lowest left over here, tower. For that it has 3 branches. In that 3 branches, left nothing is there, right also nothing is there. In the middle it is like left, root and right, left, root and right. Printing is left, root and right. Since we don't have anything for this left and right, only root is there, I printed this. Once this is done, again left branch is done, this left branch is done, I'll go to the root. What is there in the root I printed over here. Then I'll go to the right branch. In the right branch, again I'll go to the left does not have anything, then again I'll go to the root. In the root again it is move 1 from C to B, this side it. Then again I'll go to the right branch, nothing is there. Come back to this tower function, go back to this tower function, this left entire branch, whatever printf is done. Now this needs to be printed. So move 3 A to C, move 3 from A to C. So this is done. Once you go back to the function, so left branch is done, root is done, come to the right. In this right again go to the left. So what is you will come to this left section, then from this again you'll come, this is not there, then you'll come to this, then you'll come to this particular printf statement, that is move 1 from B to A, move 1 from B to A. So this is done. For this right branch nothing is there, it will come back over here, then it will print this particular statement, that is move 2 from B to C, and then it will come back, root is done, then it will come to the right. In the right, this will return actually, and this is the final statement. Move 1 from A to C. So if you see 1, 2, 3, 4, 5, 6, 7 moves, so you know 3 disk means it is 2 to the power n minus 1, so it is 2 to the power 3 minus 1 is equal to 7. So if you note down this result, you will get the same result when you give n is equal to 3. So this is the working of the Tower of Hanoi program, and this is how the recursion works. So this is how you can just try to solve for taking 2, I mean taking Tower of Hanoi for the value 2, and you will understand this tree structure properly. So again, if you want to repeat, in the tower we have three functions, that is 2 functions and again one printf statement in between. So for the function I represented the oval, and for the printf I represented the rectangle. Within this tower again you have 3 statements, so that is 2 functions and printf. Again for this tower 2 functions and 1 printf. It got ended because n value was 0. So same way you will go while reading, while printing, it is always left, root and right, left, root and right. So I came from this left, nothing was there to be read, then root I read. Firstly I came to the left branch below, left nothing was there, then root printf statement was there, I printed here, then right nothing was there. Again I went back for this. So my left section was done, then I printed with the root, my root section was done, then I came to the right. In that right again left nothing was there, root was there, so I printed this particular statement. This entire branch was done, I gone back to this particular function, and then this 4th line is being executed over here, and then I went to the right. In the right again I came to left, in that again this function, and then again root, and then this particular printf statement. So this is how it works with the Tower of Hanoi. So this function is there, right? So this function is being explained in this particular logic. Try to trace this way, you will understand. So clearly listen from the beginning, you will understand how the Tower of Hanoi works. So this is regarding the working of the Tower of Hanoi function. Let us see the demonstration of the Tower of Hanoi in the code blocks. So this is regarding the execution of the laboratory program 5. So we'll see the program over here. So here you can see the same as include IO, push, float, evaluate function, and then we had the main function. In the main function again we had 3 choices like evaluation, solving and as well as exit, and then enter the choice. So enter a valid postfix expression. You have read the postfix expression, for example whatever we have taken in the example, and then evaluate that particular postfix expression. And next case we had enter the number of disks. So we had seen regarding n is equal to 2 and n is equal to 3, and it also prints the total number of disks. And then we had push function as well as float function, and then regarding the evaluate function, what I explained in the first session of the lab, and regarding the Tower of Hanoi function. So let us run this particular program and check the output. So over here, so here I'll give the option for evaluation of the postfix expression. So whatever we solved, let us check for those outputs. So I gave enter one choice. So I'll give the what we have solved example itself, 4325 star minus 4325 star minus and plus. So this was the first one which I had given. Under a valid postfix expression I gave result is -3. So if you go back to the example and check, we got the result as -3. And one more, we'll try with the one more choice, one more which were given the expression, that is 537 plus star 284, 537 plus star 284 division, and then plus, and then again star, and then again 6, and then again modulus, and then 2, and then power symbol. So if you see, this is an example 2, 537 plus star 284 division plus star 6 modulus 2 power. So we got the answer as 4, if you remember. So this was the answer. We'll try to give for also invalid expression. So for example 3, 4 minus and plus, we'll try to give a minus and plus. So it's an invalid because for a proper valid postfix expression it should be 3, 4 minus. That means what? pop 2 operators and place this pop 2 operands and place this operator in between them. So you will get -1 as the answer, and -1 plus it is there, -1 and plus it is there. So it is not an invalid postfix expression. That's why it prints invalid postfix expression. So this is, you need to check for a valid expression. Also, you can also try with the invalid. Try to give 3 possible outputs for this. Okay, next is regarding the solving tower of Hanoi. So enter the number of disk. I'll give n is equal to 2. So you know n is equal to 2, it was 2 to the power n minus 1. Totally you got 2 to the power 2 minus 1, 3 moves. If you see the example what I've solved over there, you got move disk 1 from A to B, disk from A to C, and disk 1 from B to C. This is for the n is equal to 2. Also try to give n is equal to 3 and check the output what I've got over there. So it is 3. So if you see, go back and check over there. If you just go back and check in the example, so we have the same, that is move disk from A to C and A to B, then C to B and A to C, as well as B to A, B to C and A to C. If you just go back and see the trace section what I've written over there, the result is same. And here 2 to the power n minus 1, 2 to the power 3 minus 1, it is 2 to the power it is 8 minus 1 and it is 7. So this is regarding the execution of both the evaluation of the postfix expression as well as the tower of Hanoi problem. Thank you.